Okay, good day everyone. So let's continue our discussion on the quantum theory of light. Last time we discussed about black body radiation. So ang quantum mechanics is na formulate siya from that problem, uh, calculating the intensity of a radiation as function of temperature, frequency, and so on. So Max Planck successfully derived the equation for black body radiation. And from that, na-derive niya actually ang katong constant or nakita niya nga there is this H Max Planck constant, okay? Based from that problem, okay? So let's continue. Next is this topic, the quantum of energy, okay? The quantum of energy. So Max Planck was convinced that black body radiation was produced by vibrating submicroscopic electric charges, and they call that one as resonators. Okay, and each resonators has this energy, and Max Planck actually derived this one. The energy for a certain resonator is equal to this n times the Max Planck constant times the frequency F. Sa yun lang kay nga energy, no? Sa yun lang kay nga expression sa atong energy. So, this, the energy for each resonator is equal to n some number, say from 1, 0, 1, 2, 3, so on, okay? And then H, this is Max Planck, Planck's constant, okay? Planck's constant. And this F is the frequency, okay? The frequency. So the energy is just equal to NHF. And this resonator, it can change. The resonator can change. The resonator can change its energy. Its energy only by the difference of equal to this expression here. The change of energy is just equal to the Max Planck's constant times the frequency F. So, below sa kanang energy, say for example, dili siya maka-jump from energy level 0 to energy level 1 if the difference is less than the Max Planck's constant times the frequency F. Okay? So, it can change its energy. This resonator can change its energy by this difference equal to HF. Take note, N is equal to 1, 2, 3. Depende kung unsa nga asa nga energy level imo ang kinahanglan nga solver. So that is, it cannot lose just any amount, no? It cannot lose just any amount of energy, of its total energy, but only a finite amount, which is equal to H times F. Okay, so it, take note, it cannot lose just any amount of total energy, but only a finite amount of HF. The and this HF is, we call this one as the quantum of energy. Okay, so this is, we call this one as the quantum of energy. Okay, of energy. So if we look at this figure here, it this figure, we have these allowed energy levels according to Planck's original hypothesis for an oscillator with frequency F. So, for example, dire no, na kung energy equal to 0, and then mo jump lang siya into another level of energy. We call this one as energy level. If your energy is somewhat equal to H times F or NHF, no? So, na 1HF, tapos mo jump lang mo siya into 2HF, 3HF, 4HF, and so on, no? Kung less than ana, say for example, ang imong energy kay nara diri, no? Lapit, then dili siya maka-jump to another, dili siya maka-change to another energy, amount of energy, kay kulang raman siya, no? Di raman siya mabuha raman siya ng HF, no? Kung dili lang yung energy, then the energy is just equal to 0. Okay? So, dili siya maka-change to another level of energy. So, we call this one as energy level. Okay? So, energy level 0, uh, 1, where n is equal to 1, 2, 3, up to infinity. Okay? So we call this one as energy levels, okay, according to Planck's original hypothesis. Okay, and take note, sayon na kaya ang equation, no? The change of energy is just equal to H times F. Okay? And then depende lang kung unsang energy imong energy level imong kuhaon. Say when n is equal to 4, then the energy is equal to 4H times F. Tama? So when n is equal to 5, 5HF and so on. So muna gitawag siya nga your energy is actually quantized, no? Your energy is always is actually quantized kay na certain nga energy lang, finite amount of energy nga kinahanglan in order to change it, say maadan ka og energy or makalose ka og energy, no? Losing or adding energy, jumping up, tama, and then pwede po ka mo down, no? Pwede ka mo lose og energy, but your energy is quantized and it is finite. Ang ayang amount is finite, and that finite amount of energy is just equal to H times F. Say for example, for green, for example, we uh, calculate the change of energy for, say for example, the color green, which has the frequency of a green color is no, not the frequency, but the wavelength. The wavelength of this green color is actually equal to 540 nanometers, or that is equal to 540 times 10 to the minus 9 meters. Okay, so for green color, the change of energy for green is just equal to HF. Tama? The change of energy for green color is equal to HF, and we know that in terms of lambda, F is just equal to the speed of light times the lambda uh, wavelength lambda. Okay, so we can write not in terms of frequency, but in terms of lambda, it is equal to H C over lambda. Okay, take note, your F can be written as C over lambda. Okay, so using this, we have H is equal to 6 point, this is the Planck's constant, times 10 to the minus 34, the unit is joule second, times the speed of light, this is 3 times 10 to the 8 meters per second, over the lambda, which is equal to, for green, take note, the wavelength is equal to 540 nanometers, or 10 to the minus 9 meters. So as you can see, if you solve this one, the change of energy, okay, is equal to 3.68 times 10 to the minus 19 joule. If you convert it to electron volts, we know the conversion factor between electron volts and joule, because 1 electron volt is equal to 1.6 times 10 to the minus 19 joules. So therefore, the E green is equal to 2.30 electron volts. So this is the change of energy for green color, 2.3 electron volts. So meaning ani, if your energy is 2.3 electron volts, then you can jump up to another energy level. Okay? Mag-add na po kag 2.30 electron volts, mo jump na po siya into another level of energy. If it is less than 2.3, then dili ka change into another energy level. Okay? So that's for um, E green. Okay? It's equal to 2.30 electron volts. Now, your assignment will be this. Okay, assignment. What about for red? Okay, calculate the change of energy for red color. Take note, this will be your assignment, no? For red, the wavelength for red is equal to 700 nanometers, okay? Or this is equal to 700 times 10 to the minus 9 meters, okay? So again, this will be your assignment. What will be the uh, change of E red, okay? Change of energy for red color, where red has a red light, sorry, it's red light, where red light has a wavelength equal to 700 nanometers. Okay, let's now go to photoelectric effect. So in 1905, Einstein published three papers. Okay, he published three papers in 1 year lang, no? Nakapublish ang tulo ka journal, and these three papers is all about um, his discussion or his study on Brownian motion. One paper is for Brownian motion, another paper is for special theory of relativity, special theory of relativity, and the last paper, relativity. Ang ikatulo niya nga paper, it's all about photoelectric effect. Okay, that is in 1905. So, by the way, na Nobel Prize siya not because of his Brownian motion nga study, also not because of his special theory of relativity, although famous siya aning topic, kaning special theory of relativity, but na Nobel Prize siya because of his study on photoelectric effect. Okay, photoelectric effect. So, in 1921, he won the Nobel Prize because of this study, because of his study on photoelectric effect. Okay. We have to take note that light itself composed of grains, irreducible, finite amount. Okay, last time we discussed quantum of energy. Okay, so irreducible finite amount, or we call this one as quanta of energy. Also, light. So we talk about light, no? Interacting with matter also consists of somewhat called quanta. Okay, quanta. So the particle sa light, take note, ang particle of nga nasa light is called photons. Okay, so this is your light. Okay, this is your light. Okay, then kaning particle nga nasa light is we call this one as photons. Sometimes we also call this one as photoelectrons. Okay, so ang pirang famous nga name is or photons. Okay, so in photoelectric effect, so we have this apparatus of this photoelectric effect. What will happen is ilang na observe sa una is when there is light with some quanta of energy. Okay, kung enough imong light, energy sa light, kung enough imong light sa kung enough ang energy nga naa sa imong light, okay, kung enough ang energy nga nasa imong photons, posible siya nga maka-knock out og electrons ani ako ang metallic emitter, okay, or metallic material. If I have metallic material, so samot ingani siya form lang, no, na ako'y metallic material, and then when you have a light there, and then this light has an energy, okay, this photons has an energy, and it is enough, is greater than the binding energy of the material, then the electrons here will move. Okay, the electrons here will move, and what will happen is if there is moving electrons, there will be current. So that's photoelectric effect. So muna ang basic or concept of photoelectric effect. When the light has enough energy, it can knock out electrons from this metallic material, or a conductor, or any material, conductive material. Okay, so knocking out electrons meaning your electrons will move, and take note, moving electrons will produce a current. Okay, moving electrons will produce a current. So that's why para sa solar panel, no, ang solar panel, ang concept lang sa solar panel is, basic na concept sa solar panel is this: we have the light from the sun. Okay, we have the light from the sun, and if the light is has an energy enough or greater than the binding energy of the material, then the electrons na naato nga material kay mangambak to siya, no, manglihok to siya, mangmove to siya, ma-emit to siya like this apparatus here na light dira, and then the electrons will move to this one, and then moving electrons will create a current. So that's why nakoy theory, uh, yeah, nakoy moving electrons will have or will produce a current. So that's why naday ko na generate nga electricity and what. Okay, so one good example for photoelectric effect, one good application is these solar panels. Okay, solar panels. Ang concept lang is, concept po solar panels is just this photoelectric effect. So ito, nakoy light with energy, quanta of energy. Kaya nasa a certain energy sa imong light. And then if that is high enough or greater than the energy ani nga material, we call this one as binding energy. Ang energy nga nag-hold sa electrons ani sa imong material, if it is greater than the binding energy of the material, then the electrons will free to move, and moving electrons will produce a current. So how will you do the equation for this one? Okay, if I have the energy here, then this one is moving, the light or the photons from light is moving with some velocity v, then there will be a kinetic energy. Okay, so when the photoelectric effect, we have this one equation for this. We have the maximum kinetic energy that uh, has that photon has. Okay, that the photon has in this light. For example, the maximum kinetic energy is just equal to this 1/2 times mv square, no, mass of the electrons times the v max square. Okay, so this is the maximum kinetic energy of the photoelectrons. Okay, the photoelectrons, it is equal to 1/2 mev max quantity square. And using conservation of energy, the kinetic energy here will then be converted, ang kinetic energy sa imong photoelectrons will then be converted to some potential energy by conservation of energy. And the potential energy here is just equal to the electrons, E, times the stopping potential V. Okay? So what do you mean by stopping potential V? So you can write, take note, you can write maximum kinetic energy as 1/2 mv square, or you can write the maximum kinetic energy into the potential equal to EVS. Okay? So this is the maximum kinetic energy of the photoelectrons. Kinetic energy of the photoelectrons. Okay? And it can be written as the potential energy E times Vs, where Vs is somewhat, this Vs here is called the stopping potential. So what do you mean by stopping potential? So kung ako'y circuit with some voltage V, okay, if your V, if your this one, if your V is Vs, then it means that ang katong electrons nga mangdagan ani no, kani mga na-emit nga mga electrons will now be, it will not be moving. Okay, kay ngano gayto, kay ang imong kinetic energy is then converted to potential energy. So ang mahitabo, magkahinay ang iyang dagan, magkahinay ang movement, ang motion sa imong electrons dari. And if it is the voltage, if the voltage is some stopping potential, it means that there will be no electrons nga mang jump, there will be no electrons nga mang move ani nga setup dari. So we call that one as stopping potential. But anyways, the equation is very simple. For the maximum kinetic energy, it is just equal to 1/2 mv square, or you can write this as the charge of the electron, which we know electron is equal to 1.6 times 10 to the minus 19 coulomb. Okay, and the stopping potential is gonna depende sa imong circuit, no. uh, ang stopping potential is muna ang maximum nga potential para dili mo lihok or para mo stop or walay motion ang imong photoelectrons. Okay, so yeah, that's it. That's for the photoelectric effect, no? So sa ito, photoelectric effect is just this: the energy to eject an electron, the light must supply enough energy to overcome the force holding the electrons in the material. So if this is your material, this is your material, no? Kaning metallic emitter dari nga apparatus. If this is if this is your material, if the binding, we call this one as binding energy. Okay? Ang binding energy is ang energy nga nag-bind sa imong electrons sa mga particles sa imong metallic material. Okay? So if your energy sa light, from the light, is greater than the binding energy, then somewhat ang mga electrons aning imuhang metallic conductor or metallic material will move, it will go to that one, so and then it will create electricity, it will create current and so on. Okay, if it is less than binding energy, uh, then walay mahitabo, no, electrons kay mutapot ra na sa imong metallic material. Okay, So dapat greater than or enough imong energy from this light nga maka-knock out aning electrons gikan sa imong metallic emitter. Okay? So kung in lang, for example, kaning ballpen lang, tapos na isa, for example, kita, no? Ah, samot mura sa related sa, mura sa, pero dili sa electrons. So for example, magpainit ka, no? Magpainit ka mura sa related sa kaning vitamin D, no? Vitamin D, kung magpainit ka is kanang makakuha daw ka og vitamin D daw sa imong lawas, no? Tama ba? So somewhat more sa ingana, no? So since na energy gikan sa solar sa sun, and then more sa mura sa mo react sa tuang panit such that mo makadungag siya og vitamin sa imong lawas. Mura sa ingana nga setup, no? But in this case lang na metallic material, then gikuha na nimog light, then naay mahitabo sa yaha if the energy is greater than the binding energy. Naay mahitabo nga moving electrons, naay mga electrons nga mga tanggal ato nga material. So somewhat same sa atong planet, no? Ambot unsay matanggal sa ato ang planet siguro kung magpainit ta or what. Okay? So kanila, no? Kanila yun. K max is just equal to 1 of mv square, or you can write this as electron times the stopping potential. Take note, ang mga knockout lang is only the electrons. Okay? Only the electrons. Okay. We also know that energy can be written in terms of frequency. Energy is just equal to some Planck's constant times the frequency. So therefore, I can also write K max, okay? In terms of frequency, I can also write the maximum kinetic energy equal to the max Planck, the Planck's constant, times the frequency. And there is this so-called phi, okay? There's this so-called phi, and this phi is called the work function, okay? Work function is property po ni siya sa imong material, okay? Si work function depende sa material nga imong gigamit, no? Si work function is a property of the material of the metal which corresponds to the minimum energy with which an electron is bound in the metal. So mura sa binding energy gyapon, no? So the minimum energy nga naa sa imong material, okay? If it is greater than the HF, okay, what will happen? If your work function is greater than the HF, then there will be no kinetic energy maximum. So walay photoelectrons nga walay mga electrons nga mangliho, tama ba? If it is less than the HF, as you can see, if it is less than the HF, then there will be kinetic energy. So uh, there will be kinetic energy, so therefore na mga electrons ka ng lihok, na mga photoelectrons ka ng lihok. Okay? So muna siya, no? So dapat ang imuhang light kay greater than siya sa ang energy sa light must be greater than the work function phi. And take note, this work function is dependent sa imuhang material nga ginagamit. Okay? If it is equal to HF, then there wala gyapon photoelectrons ka manglihok. Tama ba? When HF is equal to the work function, then there will be no kinetic energy, so there will be no moving photoelectrons. Okay, so you can write that as that, or you can write this as the EVS. Okay, equal lang na silang duha, no? So actually kanilang duha for photoelectrons, mura gyud nato ang ginagamit yung permanently, no? The kinetic energy of photoelectrons is just equal to 1 half mv square, which is equal to EVS, and Vs is the stopping potential. Or you can write this in terms of frequency hf minus phi, where phi is the work function. It is the minimum energy of which an electron is bound in the metal. Okay. For example, so ang atong gamit ng material is zinc. Okay. So what will be the photoelectric effect in zinc? So si Leonard, Nobel Prize yapon na siya in 1905, si Philip Leonard, determined that photoelectrons released from zinc by ultraviolet light were stopped by a voltage of 4.3 volts. Okay, so ang meaning ani kay nakoy zinc, no? Nakoy zinc nga metallic material, and then nakoy ultraviolet light. Okay, nakoy ultraviolet light. And then ang nahitabo is na-observe ni Philip Leonard that if the voltage is 4.3 volts, then there will be no photoelectrons nga mang. So this is your detector. Gi-connect mo siya sa circuit, for example. Okay, connecting our circuit. Okay, so if the stopping potential is, if Vs is equal to 4.3 volts, then there will be no motion of photoelectrons. Walay mga knockout ng mga electrons ani akong zinc nga material. Okay, so muna pasabot, no? Again, butangan na sa ultraviolet light. Ultraviolet light. Okay, there will be no motion of photoelectrons when the stopping potential is equal to 4.3 volts. Question is calculate the K max and calculate the Vmax. This is very simple. Vmax. It's very simple because we know Kmax is just equal to, you can write this in terms of the stopping potential, E times Vs. So we know this one. This is 1.6 times 10 to the minus 19 coulomb times the stopping potential, which is 4.3 volts. So therefore, the maximum kinetic energy of the photoelectron is equal to 6.9 times 10 to the minus 19 joules. Okay, and then if you solve for the Vmax, take note, Kmax is just equal to 1 half m Vmax square. Okay, so from this one, we can solve for the Vmax, which is equal to square root of 2 times the Kmax over m. In this case, m here is the mass of electrons. Okay, mass of electron. So therefore, the maximum speed of the photoelectrons is equal to square root of 2 times K max na 6.9 times 10 to the minus 19 joules over the mass of electron is 9.11 times 10 to the minus 31 kilogram. So if you do that using calculator, the maximum speed of our photoelectrons is around 1.2 times 10 to the 6 meters per second. So, ingani kapaspas ang dagan sa akong mga electrons, photoelectrons, aning ako ang photoelectric effect nga, photoelectric setup, no? Take note, the speed of light is 3 times 10 to the 8. So, somewhat, the relativistic effect on this are somewhat negligible. Or pwede gapon mo siya butangan og relativistic na uh, uh, term, but dili na to butang ano because kani gamay-gamay ra man ni times 10 to the 6. Okay? If okay, so that's how to calculate the K max and the V max using the equation for the photoelectric effect. For zinc, okay? For zinc, so we also have this another question for this problem. If zinc has a stopping potential, if zinc has a stopping if zinc has a work function equal to this 4.31 electron volts, okay? Electron volts, 4.31 electron volts. Then, what is the frequency? What is the frequency F? Okay, so what we need to solve, itong kinahanglan nga solvon is what is my frequency F. Okay, we know that the equation for, in terms of frequency, K max is equal to HF minus some work function phi. Okay, so in this case, in order to solve for frequency, this is very simple. Frequency is just equal to K max plus the work function over the Planck's constant h. Okay, times the Planck's constant h. So therefore, frequency is equal to, we know K max. K max is equal to 6.9, no? 6.9 times 10 to the minus 19 joule. Muna ito nakuha last time sa ito ang previous nga example. Ito ba? Yeah, 6.9 times 10 to the minus 19 plus this is 4.31 electron volts. You have to convert it into joules. Tama? I-convert dapat na ko na siya into joules, and I know that 1 electron volt is equal to 1.6 times 10 to the minus 19 joules. Okay? So you have to convert it, the electron volts, into joules. over the Planck's constant, which is equal to 6.63. So I will use 6.63 times 10 to the minus 34 nga Planck's constant age. The unit is joule second. So if you do this one, you use your calculator, this is actually equal to 2.08 times 10 to the 15 hertz. Okay, so this will be the frequency of the light, no? Of the light if if the zinc material has a work function equal to 4.31 electron volts. Okay, so that's the photoelectric effect. So tayo na sa no? Kmax, the maximum kinetic energy of the photoelectrons can be written as 1 half mv squared or equal to the E times the stopping potential. E is the charge of electron, okay, times Vs, or you can write it in terms of frequency and work function equal to Hf minus phi. Okay, so kana lang itong dumduman, duha lang kabuk, no? K is equal to 1 half mv squared or EVs, or you can write this as Hf minus the work function phi. Okay, so that's for the photoelectric effect. Okay, let's now go to Compton effect and X-rays. Okay, the Compton effect and X-ray. So this figure here is an example of an X-ray, no? So ang X-ray same lang gihapon, no? Na ako'y ang mahitabo is na ako'y high speed electrons, okay? Wilhelm Röntgen found that a beam of high speed electrons na ako'y gikan ani nga source, no? Gikan ani nga source. So this is X-rays and Compton effect. Compton effect. So I will discuss first X-rays and then I will discuss next the Compton effect. So sa X-rays ngani, I have electrons gikan ani nga source, ako'y filament, and then your electrons kay gamove siya with high speed, okay? Paspas kay nga speed sa imong electrons, may dako po siya nga energy ang kinahanglan, no? Para maka-produce ka og high speed electrons. And then when these high speed electrons strike a metal, okay? When this high electron strikes metal, what will happen is it will produce an unknown rays, okay? And that unknown rays is called X-ray, okay? So ang mahitabo gikan aning high speed electrons ni hit siya sa target, any metal target. Pag hit ka sa metal target kaning high speed electrons, pag hit sa metal target, what will happen is there will be an emitted X-rays, an emitted rays, okay? And we call that one as X-rays. And these X-rays can be uh, ang kaning mga X-rays kay pwede siya mo penetrate sa atong lawas, makalapos ra sa atong lawas, except sa bones. Ang bones kay dako man siya og absorption constant. It means that we call that one as attenuation. Since ang X-ray kay dili siya makalapos sa bones, so that's why pag X-ray nimo ang may tabo, manglapos ra man ning X-ray sa muscle lang, no? Manglapos ng X-ray sa muscle. So that's why makita kag puti nga color kung muscle lang na siya, no? Kung unod lang na siya or tambok lang na siya, manglapos ra ng X-ray. Okay? But kung bukog siya, ang bukog kay dako siya og absorption constant. So ang mahitabo kay i-absorb lang sa bukog ning X-ray. Okay? So munang black ang imong makita, black ba or white? White imong makita ta. White kay gina-absorb raman sa sa bukog ning atong kaning X-ray, no? So muna pag hit sa atong lawas, muna atong lawas. So pag muna ang X-ray gikan sa atong high speed electrons, no? Muna ang X-ray dira, muna mahitabo sa kuano sa hospital, no? Ang mahitabo na detector dari, okay, katong film, okay, na film dira sa imong likod. Ang mahitabo is ang uban X-ray manglapos sa imong detector, ang uban nga X-ray kay i-absorb siya sa imong bukog, okay? Ang uban nga X-rays i-absorb siya sa imong bukog. That's why pag trace sa detector dari, munang pag trace sa detector dari na itong tanan except sa atong bones nimo, no? Except sa imong bones kay mura sa nagpaluma ka ba, nag-copy ka sa imong lawas. Since X-rays kay mo penetrate sa muscle, so mo penetrate sa muscle, ma-draw siya mo penetrate sa muscle, makita siya sa imong detector, okay? But since ang X-ray kay dili siya or i-absorb lang siya sa imong bone, sa imong bukog, so makita gini mo nga lahi ang color sa bukog o color sa muscle sa kani X-ray nga film. Okay? So that's X-ray. So pero ang concept is makaproduce ko og X-ray gikan sa high speed ng mga electrons. Okay? Makaproduce ko X-ray, sorry, from a high speed electrons at striking a metal target. So muna ang hinungdan nganong makaproduce ko og X-ray. Okay? So ingana lang no. And then take note sa iyang voltage is around 50 kilovolts to 100 kilovolts kay kinahanglan man ko og paspas nga dako kay nga energy para paspas kayo ang electrons mangdagan to produce X-rays. Okay? To produce X-rays. So nakuha ninyo no? Sakto ba ang sakito nganong makatrace ka og nganong makuha nimo ning maklaro nimo ang bukog nimo, it's because of this one. X-rays mo penetrate lang sa muscle, i-absorb ang X-ray sa bones. That's why pag draw nimo sa film, lahi ang makita nimo sa muscle ug lahi mo ang makita nimo sa bones. So napayuban nga X-ray ang gamit tapos i-X-ray nimo imong tiyan kaning imong intestine no. I-X-ray nimo imong large ug small intestine. Kung makita nila kung unsay sulod. Ang imong buhaton is kinahanglan ka mo inom mo, I think it's iodine para mo dako ang absorption constant sa imong tinai. Okay? So pag nakaimnon to increase the absorption coefficient para pag pag-bombard pag emit sa X-ray ang may tabo kay absorb lang niya sa imong ang X-ray kay absorb lang niya ang X-ray i-absorb lang sa imong intestine. So ingana no, pwede nimo i-increase ang absorption constant sa imong body para mas klaro ang imong X-ray nga image, okay? X-ray nga image. So ingana lang no, ingana lang siya pag what's the physics behind the X-rays, okay? Okay, let's now go to Compton effect. Okay. Compton effect. So nay diferensya or nay kalayan between photoelectric effect and Compton effect. When you say photoelectric effect, so ingani ang may tabo sa photoelectric effect no. We have a photon. Okay, na ako yung photon. Then unsa ito? If I have a material, then when this photon hits the material, what will happen is ang mga electron kay na yung mga knock-out ng mga electrons. So muna ang concept sa photoelectric effect, right? So this is for photoelectric effect. But in photoelectric effect, may mga knock-out ng mga electrons, but the photons ani is ma-absorb siya sa imong material. So that's photoelectric effect. I-absorb ang photon sa imong material, and then because of that, may mga knockouts ng mga electrons sa imong material. So that's for photoelectric effect. So i-absorb lang niya, no? But for Compton effect na siya kalayaan, no? If I have a photon, tapos mo hit siya target, na yung mga knockouts ng mga electrons and at the same time na yung mga photons nga mga scattered pagawas. Okay? So that's for Compton effect. So muna ang kalayan sa duha lang, no? For photoelectric effect, ang photons kay ma-absorb lang siya sa material, then may mga knockout nga electrons. But for Compton effect, dako siya nga energy nga kinahanglan, na yung mga knockout nga electrons and at the same time na yung mga mas scattered nga mga photons. These are photons. Okay? Na yung mga scattered nga photons pagawas. Okay? So we call this one as scattered photons. Okay? So that's mura na ang kalahian sa photoelectric effect and Compton effect. So if I draw it clearly, so we have an incident photon. If this is an incident photon, okay? And then there is an electron. So electron lang sa ano, isa lang kabuok. This is an electron which is initially at rest. Okay? Initially at rest kay wala pa man siya na gihit aning ako incident photon. After hitting the electron, this incident photon has a wavelength and it also have a momentum. Okay, it also have an energy. Okay, if it hits the target, okay, kung ma-hit na sa target karon, what will happen is sa Compton effect, there will be a recoiling electrons. So na ay electrons nga manglihok, no, na mga knockouts nga electrons, na mga knockouts nga electrons. They call this one as recoiling electrons. So mura na sa no, mura na sa photoelectric effect na mga mangtanggal nga mga electrons, and at the same time electron lang. Ang photon nimo kay mugawas na mga mas scattered nga photons. Okay? So this is for Compton effect. Scattered photons. So when it hits the electron, when the incident photon hits the electron will move, okay? By you can also use conservation of momentum here. There will be a recoiling electron, moving electron, and at the same time, the photon will be scattered at some angle theta, or at some angle phi. Okay, at some angle phi, and this one is some angle theta. Okay, so that's the concept of Compton effect. And the equation, okay, and the equation here, you will use the equation. This scattered photon is dili na siya pareha sa imong incident photon since na-reduce niya ang energy. Okay, because of this collision, there will be a reduce of energy. So once ma-reduce ang energy, mo change mo ng frequency, right? So ito, when nako energy nga sa nga aning incident photon nako, and then when it hits the electron, mo reduce akong energy. The scattered photon now has a reduced energy, mas gamay sa energy compare sa incident photon. And take note, energy can be expressed in terms of frequency. So kung mo reduce ang energy, mo reduce po ang frequency, and mo reduce or mo change po ang ako ang wavelengths. I think mo increase ang ako ang wavelength. So if the wavelength of incident photon is lambda, then the wavelength of this scattered photon is somewhat, I call this one as lambda prime. So they are not equal. The lambda and lambda prime here are not equal because lahi man ang energy sa incident photon ug sa akong scattered photon. So the lambda will change, momentum will also change, and energy will also change. I call it known as E prime. And the equation between the change of wavelength, okay, the change of wavelength, the lambda prime minus lambda, so this will be the Compton scattering. We call this one as Compton scattering equation. There will be a difference of uh, wavelength, or the change in wavelength, lambda prime minus lambda, and it is equal to the Planck's constant over the mass of the electron times c, or c is the speed of light, times 1 minus cosine of the phi. Not the theta, no? Ang theta kay ang angle sa imong electron nga na knockout. Ang phi is ang angle of your scattered photon. Okay? So, nakoy h over mc times 1 minus cosine of phi. So, we actually call this one as Compton scattering. So, naay mga na-scattered nga photons, and the change in wavelength is equal to h over mc times 1 minus cosine phi. Kaning phi diri is not the work function but some angle lang, no? Some angle phi. Okay? Again, in photoelectric effect, there will be no scattering of photons. Okay? Gamay rang energy man niya, so munang i-absorb lang siya sa imong material. But for Compton effect, there will be a scattered photon, and to solve the wavelength of that, you will use the Compton scattering equal to this equation here. Say for example, so we have X-rays of wavelength. So given is the wavelength is equal to 0.2 nanometers, and are aimed at a block of carbon. Okay, so nakoy carbon nga material. The scattered X-rays are observed at an angle 45 degrees to the incident beam. Calculate the increase in wavelength of the scattered X-rays at this angle. So as I said, no, the lambda prime here is greater than the lambda because energy is reduced. Kung ang energy kay ma-reduce, ang frequency po is ma-reduce. And take note, frequency and lambda frequency is equal to c over lambda, right? So when when the frequency is reduced, the wavelength will increase. So there will be an increase of wavelength. So what will be the increase of wavelength of the scattered X-rays at this angle? Okay, this is very simple because we know that the change in lambda, or the lambda prime minus lambda, okay, is equal to h over mass of the electron times the speed of light, 1 minus cosine of phi, the angle, okay, the scattered angle, where we know the phi. So ang phi ani is equal to 45.0 degrees. So therefore, the change in lambda is just equal to, we know h is equal to 6.63 times 10 to the minus 34 joule times second over the mass of electron, which is 9.11 times 10 to the minus 31 kilograms, times c is the speed of light, 3 times 10 to the 8 meters per second, times 1 minus cosine of 45 degrees. Then the change in wavelength, change in the difference, no, is equal to 0.00071 nanometers. Okay, so yeah, the change in wavelength is just equal to 0.0000071 nanometers. So if you solve for the new wavelength, the wavelength of the scattered X-ray, okay, so yeah, the wavelength of the scattered X-ray is equal to the incident wavelength plus 0.00071 nanometers, and this is equal to 0.200 nanometers plus 0.00071 nanometers. Our answer, the new wavelength now, wavelength now is increased to 0.2007711 nanometers. So there will be an increase in wavelength because your frequency is decreased and energy is also decreased. Always na siya, no? Na coincident photon nga na energy nga ni, pag mohit siya sa electrons, there will be a Compton scattering, and the energy atong na scattered nga photons kay less than siya sa atong incident nga energy. Okay? So that's for the Compton effect. So sa kalayan sa photoelectric ug Compton, photoelectric effect, i-absorb lang ang photons, okay? Ang rays, or ang photons nimo sa imong material. But for Compton, there will be an scattered photons na mogawa sa imong material. Okay, so that's for the Compton scattering. Okay, we also know that we have this particle wave duality. Okay, light is a particle, and a wave. So pwede siya ma-particle, pwede po siya ma-wave. So mo ni na-observe ni nila, no, nga si light kay particle siya, and at the same time wave po siya, no, na observe nila nga una ko diffraction double from the double split experiment, ang makuha nila is actually a wave. Okay, na wave with some wavelength and so on. And also kung single slit experiment lang, ang makuha lang nila is a particle lang, na sila makuha nga linya lang, no, na sila makuha nga linya. So they concluded that light is a particle and also a wave. Para lang, no, particle wave duality. So I think, yeah, light is a particle and a wave. Last topic is we have this photon momentum. P, which is momentum, is just equal to E over C. This is based from the energy equal to this. If you recall, the energy is equal to P square C square plus this one, MC square quantity square. Okay, if you remember, nako energy, general expression by energy equal to this. But since this is a photon, it means that the mass is zero. Photon is massless, so we can write that as we can approximate m as zero. So therefore, your energy is equal to P times C. And based from that, makuha na ko si momentum. Kuha na ko si momentum equal to E over C. So that's the photon, the momentum of a photon. And if we know that energy can be written as HF, okay, uh, quanta of energy. So HF energy is equal to HF. So therefore, momentum can be written as HF over C. Okay, or you can write this as H over lambda because lambda is equal to F over C, no? Because lambda is just equal to C over F. Sorry, C over F. So 1 over lambda is equal to 1 over lambda is equal to F over C. Reciprocal lang sa imuhang C over F. So you can write photon momentum equal to HF over C, or in terms of wavelength, you can write that as H over lambda. Say for example, a laser pointer with a power output of 5 not mega, but milliwatts emits a red light which has a wavelength of 650 nanometer. Okay? So, ang red light has a wavelength of 650 nanometers. Calculate the momentum of each photon and how many photons does the laser pointer emits each second. This is very simple because momentum for letter A, momentum is just equal to h over lambda. So we have 6.63 times 10 to the minus 34 joule times second over the wavelength is 650 or 6.50 times 10 to the minus 7 meters, no? Or 650 times 10 to the minus 9. Okay? So the momentum is just equal to 1 point. If you do that, 1.02 times 10 to the minus 27. The unit is kilogram meter per second because joule is equal to kilogram meter per I think it's meter square per second square. Multiply mo siya by second, so na ako'y kilogram meter square per second. I-divide mo siya by meter, so ang mabilin is only kilogram meter per second, which is a unit of momentum. So that's our momentum. And how many photons does the laser pointer emit each second? We know that energy can be expressed, so this is for letter B, energy is equal to PC. We have to get first energy because take note power is given. Power, that's equal to 5.0 milliwatts. And power is just equal to energy over time. Okay? Power is just equal to energy over time. So if we solve for energy, we have it is equal to PC 1.02 times 10 to the minus 27 kilogram meter per second times the speed of light, which is 3 times 10 to the 8 meter per second. So this is equal to 3.06 times 10 to the minus 19 joule. So this is actually equal to, if you convert it to electron volts, this is equal to 1.91 EV. Okay, so that's the energy. Okay, and we know that the laser pointer is given emits energy at a rate of at a power output of 5.0 times 10 to the minus 3 joule per second or watts, no? So laser pointer, we know the laser pointer emits energy at a rate of energy is power, no? A rate of that one given 5.00. Milli is times 10 to the minus 3. Watts is actually joule per second. Okay? So therefore, if you do this, we have 5.0 times 10 to the minus 3 watts or joule per second divided by the energy, okay, per photon, the energy per photon, which is we solved that one, okay, the 3.06 times 10 to the minus 19. This is the energy per photon. Kada photon, so nag-emit na sa energy, nasa ginakiring energy equal to 3.06 times 10 to the minus 19 joule. So we have 3.06 times 10 to the minus 19 joule per photon. If you do the math, this is equal to 1.63 times 10. Joule will be cancelled out. Joule will be cancelled out. 1.63 times 10 to the 16 photons per seconds. Okay? Meaning, so this will be your answer. Kada segundo, na ako'y 1.63. Nga ni kadaghan, no? 1.63 times 10 to the 16 photons per second. So, how many photons does the laser pointer emit each second? Kada segundo sa imong laser pointer, na ako'y ingani kadaghan nga photons nga iyang ma-emit times 10 to the 16 photons per second. So, nga nakadaghan ang photons nga nasa imong laser. Kada segundo, muhit siya sa imong target, and ang kadaghanon niya is up to 10 to the 16 photons per second. So that's for the photon momentum. Okay? Okay, so I think that ends our discussion on chapter 3. So good luck sa ato ang mga quiz na nagdayon. Okay, thank you so much for listening.